What you're seeing in the video is the front fork of my bicycles. I do like going for a ride, and I've gone through so many speedometers on this bicycle, so I decided that today I'm gonna build one. The way most of speedometers on bicycles work is they have a reed switch and a magnet here on the wheel, and that counts how many times and how fast has been between each time you pass. Therefore we know the diameter of the wheel, and we can calculate how fast we're going, and of course we can keep track of distance as well. This is the other end of the reed switch, and I'm gonna solder this to here, making my life easier during the test so I can disconnect and connect the prototype. Mission accomplished. Now let's test it. Okay, so I set it up on short, so if I touch these two you can hear it beeping. Alligator clips to those two connectors here, and what I'm gonna do now is gonna lift the bike a little bit and turn the wheel, and you can hear that's each time I'm passing by the reed switch with the magnet. So I wrote a few lines of code to read pin number 2, and it's pulled up, so it's an input pull up. So if we touch ground, you can see it will show 1. It's a reverse logic. This way I don't have to put an external pull up. I can use, or pull down, I can use the internal pull up. I can see. So now what we're going to do is I'm going to connect this to one side of the bicycle reed switch, one from ground, and every time the magnet will go through the reed switch, I'm going to see 1 here. Let's test it out. Okay, so I improvised a little bit. Bicycles are up in the air, so I can run this easily, and you can see I'm right now, here's the magnet, and if you see here, I'll move the wheel a little bit, I'll move it back, you see the 1, and the magnet is there. I'll move it, 0, 1, 0, very cool. Now let's write some code. Okay, here is the code. I've declared the LCD. It's just technical thing. These values, I use it through the function speed. Now this is one of the more important variables. It's the circumference of the wheel, which means from a certain point of the wheel until I get to that certain point of the wheel again, how far is the distance that I covered. In my case, in my wheel, is 210 centimeters. Now this is the magnetic pin. There are several states, and this is the last gap, which is, I'll show you the calculation. When we're doing 1 kilometer an hour, we will do 1 centimeter every 36 milliseconds. Therefore, the longest gap that I can have in between one reed to another will be the wheel in centimeters times 36, and I will be traveling at 1 kilometer an hour. Slower than that, I'll just show 0, and I'll show it to you in a second where I use it. If we're on the move, total time, total centimeters, and LED pin. In the output, I can see I have a LED pin. It's just for the debug now. It's output. I got the magnetic, the reed switch, and it's an input pull-up, and I'm giving the last state, the current state that I'm reading from that pin. Now what I do is I read the current state, and this is for putting me back to if I stopped. So meaning if the last state changed in time plus the gap that I showed you before is smaller than milliseconds, meaning if the last change that happened is slower than the last time I need to see it, I just mean I've stopped, I put speed to 0, and it's moving to false. Now, I've putting the LED pin into the state. Now, if the current state that I've read and the last state are not the same, that means that I either just now started to count, or the reed switch is just passed. So if it's high, and one thing is important, I'm reading it in reverse. I'm reading the not digital state of this. So if this is high, this will be low. If this is low, this will be high. And it was done just to keep the logic of seeing it true or false easier. So if the current state means it's high, and if we are on the move, this is for debug, and I'm just keeping it. I'm calculating the speed by taking the circumference of the wheel in centimeters and dividing it by the time that has passed since the current millis and between the last read. This for I know how long millis it took and how many centimeters, and I can do the calculation of the speed. I'm adding time and adding the centimeters that I move. Now, if I was not on the move, I'm starting the is on move through. That means the first time I'm reading and high on the read switch. And I'm keeping the last change. And I'm keeping the current state, giving it, sorry, this is the millis, I'm giving it the current millis, the timestamp. And here I'm giving the last state, the current state, so I can see it. And here I'm just showing the time, and I'll show it to you on the screen. So now let's upload the code, and I'll set up the bicycle, and let's see if it works well. So I got it all hooked up, and now I'm gonna turn the wheel. And you can see, starting to show the speed and time that has passed, and the distance as well. This is the distance, speed in kilometers an hour, and the time that I've been on the move. Now if I'll stop it, just stop the wheel. And we got back to 0. Well, I now have to wait till I get a better OLED screen. But we got a working prototype. So as I mentioned before, I've ordered a few OLED screens. I've ordered all the iScore Cs here on the list, and there are several of them, several different sizes and shapes and dot metric sizes. I hope they will get here in the next few days so I can carry on with the project. But it's a very successful end of day one, and I'm definitely gonna 3D print a case for it. So, and I want to put it on an 80-tiny 85 just for really low consumptions of power when it's working. So stay tuned. If you haven't done it before, please subscribe, leave a thumbs up, leave a comment, and see you next time.